All right, we're chugging along. So next one is 10.5, which is absolute convergence. More tests to look at. So the definition of absolutely convergent is if a series A sub n converges absolutely if the corresponding series of the absolute values A sub n also converges. All right. The absolute convergence test says that if you take the absolute value of a series and it converges, then the series without the absolute value also converges. Okay, let's look at this example here. All right, so we're going to see if this series converges using the absolute convergence test. So n equal 1 to infinity of -1 n plus 1 times 1 over n squared. All right, my a sub n is, who is calling me? Oh, okay, my a sub n is going to be -1 n plus 1 times 1 over n squared. So my absolute value of a sub n is going to be the absolute value of -1 n plus 1 over 1 times 1 over n squared. So what's going to happen to that -1 here with the absolute value? It's going to turn into 1, so we're going to have 1 times 1 over n squared, which is, this is just going to be 1 over n squared. All right, does this one converge or diverge? It converges. Why? What is your p equal to here? 2? Because this one here turns into a positive 1. And then 1 times that is just 1 over n squared. All right, so this is a p series, right? Because remember, your n is the base and it's raised to an exponent, and your exponent is greater than 1. So that means that this one converges. And according to the absolute value test, if this one converges, what can we say about this one? It also converges. You see, that's not hard. No. All right, let's look at this example. N equal 1 to infinity. Sine of n over n squared.
So it's going to be between 1 over 1?
Mm-hmm.
-1 and 1?
All right, so again, we know that sine of n is between -1 and 1, right? So -1, what am I saying? Oh yeah, n squared is less than or equal to sine of n. N squared is less than or equal to 1 over n squared.
So we had just to get the absolute value.
Yeah, so if we take the absolute value of this, is this little thing going to be here anymore? Is it going to go to -1 at all? No, so that's going to disappear. All right, so here I can use my direct comparison test to see if this one converges. So does 1 over n squared converge? Yes, this one converges. By direct comparison. And since 1 over n squared is bigger than the absolute value of sine over n divided by n squared, since this one is bigger and it converges, what can I also say about this one? This one also converges. And since this one converges, what can I say about this one? That one also converges. Watcha? Look at that.
You're able to just
No, because it has to be 1 over n squared. Well, we did use a p series here because we know that that's how we did here. But we can't use it with the sine of n over n squared. All right, not too bad, right? Okay, that's the absolute value or absolute convergence test. The next test we're going to look at is called the ratio test. Copy. Oh, so what's the difference? So a series a sub n converges absolutely if the corresponding series this converges.
So is there anything that will diverge?
Not in this example, no, because it doesn't say anything about divergence, right? So you can assume we're not going to talk about divergence there. All right, so let's look at the ratio test. So let this series a sub n be any series, and suppose, and again, no restrictions, it can be any type of series. If we take the limit of the absolute value of a sub n plus 1 divided by a sub n, and it equals a number, then we have three situations. Then A, the series converges if converges absolutely if p is less than 1. So if we get a number that's less than 1, then this series converges absolutely. So a sub n converges absolutely.
That's when it converges absolutely?
Yes, if it's less than 1. If the series diverges if p is greater than 1, or p is infinite. And if it equals 1, that means the test is inconclusive. We can't say whether it diverges or converges. All right, so we're going to use the ratio test to see whether these next few series converge or diverge. All right, so n equals 0 to infinity. We're going to do 2n plus 5 divided by 3 to the n. All right, so a sub n is 2n plus 5 divided by 3 to the n. So I need to know what my a sub n plus 1 is. How do I figure out a sub n plus 1? What do I do with that n plus 1? I insert it wherever I see an n, I replace it with n plus 1. Okay, so instead of 2 to the n, it's going to be 2 to the, and then plus 5, and then divided by 3 to the n plus 1. All right. Let's do this thing then. Okay, so let's take the limit. By the way, are these going to be positive series here? Is this always positive? From n equal 0 to infinity? Yes, this is always positive. So if I take the absolute value, does it change anything? How about this one? No. So we don't have to worry about the absolute value here. So as n goes to infinity, and we do a sub n plus 1 divided by a sub n. All right, so we're going to have the limit of n goes to infinity. A sub n plus 1 is 2 to the n plus 1 plus 5 divided by 3 to the n plus 1. Divided by a to the n, I'm just going to multiply by the reciprocal. Times 3 to the n over 2 to the n plus 5. All right, you need to be very careful here if you try to start canceling stuff out. All right, what's the only thing that's going to cancel? The 5s don't cancel. Yeah, the 3 to the n. Okay, so Here I can rewrite 3 to the n plus 1 as 3 to the n times 3. So the only thing that's going to cancel are the 3 to the n's. So I still have a 3 here. Because of the plus 5. Yeah, those plus 5s, they ruin everything. All right? Okay. So I have the limit as n goes to infinity of 2 to the n plus 1 plus 5 divided by 3 times 2 to the n plus 5. I'm going to take that 1/3 out because it doesn't really do anything with my limits. So 1/3 times the limit as n goes to infinity of 2 to the n plus 1 plus 5 over 2 to the n plus 5. All right, so if I take the limit here as infinity, what am I going to get on top if I make this go to infinity? Infinity, right? And then divide it by infinity. I could use L'Hopital's rule, but it's going to get annoying to have to deal with this right here, okay? So another thing I can do is I'm going to divide each term by 2 to the n to make it a little bit easier to deal with. So I have 1/3 and the limit as n goes to infinity of 2 to the n plus 1 divided by 2 to the n plus 5 divided by 2 to the n divided by 2 to the n divided by 2 to the n plus 5 divided by 2 to the n, 2 to the n. All right, here I'm going to get so what is 2 to the n plus 1 divided by 2 to the n? 2 plus 5 over 2 to the n divided by 1 plus 5 over 2 to the n. And as your limit goes to infinity, what is this one going to go to? 0. And this one on bottom? 0. So we're going to have, don't forget the 1/3. 1/3 times 2 divided by 1, which is 2, and that's equal to 2 over 3. All right, so let's go back up to our test to see what it says. So it's 2 over 3. This is greater than or less than 1? Okay, so this is less than 1. So if it's less than 1, what does it do? Absolutely, converges absolutely. So that means that this one converges absolutely. Y'all wondering where I got the 2? Do you see where I got the 2? Okay. All right, sound good? All right. One good thing you can do when you're dealing with that stuff is divide by like 1 with the higher degree, or in this case, just divide by whatever is raised to the nth power to make it a little bit easier to deal with.
Do we have to memorize all the...
No, I'm not going to ask you to memorize all that. That's too much to memorize. Even I have to go back and reference them. We're like, what does it mean again if p is less than 1 or equal to 1? So it's less than 1, right? So that means, according to this theorem, that means it absolutely or converges absolutely. All right, let's try this one. N equal 1 to infinity? Yes.
That 5 over the 2 to the n, that n becomes infinity?
Yes.
And then
Because that goes to 5 over 2 to infinity. That's equal to 5 over infinity, which is equal to 0. That's why we got 2 plus 0 divided by 1 plus 0. All right, let's try this one here. This is a little bit more complicated. 2n factorial divided by n factorial times n factorial. All right, so my a sub n, again, I'm going to use this ratio test to help solve this one. All right, my a sub n is 2n factorial divided by n factorial times n factorial. So my a sub n plus 1 is going to be 2 times, what do I write instead of n? N plus 1 factorial divided by n plus 1 factorial, n plus 1 factorial. All right, don't let the factorial scare you. Okay. Is this one always going to be positive, by the way? A sub n, will it always be positive? How about a sub n plus 1? Yeah, so do I need to put the absolute value? No, okay. So the limit as n goes to infinity of a sub n plus 1 divided by a sub n. So that's going to be the limit as n goes to infinity of my a sub n plus 1 is this whole thing, which, by the way, I'm going to change this, distribute the 2. So it's going to be 2n plus 2 factorial divided by n plus 1 factorial and then n plus 1 factorial divided by a sub n, so I'm going to multiply it by the reciprocal. N factorial times n factorial divided by 2n factorial.
So you can cancel 2n factorial?
Well, we need to check to see how it cancels out, okay? All right, so let's figure this out. So 2n factorial, right? I'm going to do this over here. 2n plus 2 factorial divided by 2n factorial, right?
Wait, how'd you get 2n plus 2?
I distributed the 2 over here. Yeah. So I want to see if anything will cancel with the 2n plus 2 factorial and the 2n factorial.
So wait, what happened to the n factorial?
We're gonna do those in a little bit. I just want to work with these two first to see if anything cancels out. All right, so this is kind of like a side thing here. Okay, 2n factorial can be rewritten like this. Remember, factorial is all the numbers, so like 3 factorial is equal to 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1, right? You always go one less or one more, depending on how you start it. I'm going to go with the one less. So it's going to be 2 plus 2n plus 2, right? And then times, what's one less than that? 2n plus 1. And then times, what's one less than that? 2n, right? And then 2n, I can just leave it as factorial, right? Because it's going to be the rest of 2n. And then divided by 2n factorial, what's going to cancel out? So 2n plus 2 factorial divided by 2n factorial is, you're left with 2n plus 2 and then 2n plus 1. Because all the other terms are going to cancel out. You don't have to yet. Okay, so I was working with these two, right? Okay, let's work with the other two. Let's work with these to see if anything cancels. All right. So n factorial divided by n plus 1 factorial, and then n plus 1 factorial.
Just do the same.
Let's work with the bottom part. So n plus 1 factorial times n plus 1 factorial is going to be n plus 1 times n factorial, right? You go one less. And then the second n plus 1 factorial is going to be n plus 1 times n factorial. So what's going to happen with the n factorials? They cancel. So this equals 1 over n plus 1 squared. Or 1 over n plus 1 times n plus 1. Okay, let's put them together. So this is going to equal 2n plus 2 divided by 2n plus 1 divided by n plus 1 times n plus 1. Can I factor out a 2 from this one? Yeah. So 2 times n plus 1 times 2n plus 1 divided by n plus 1 times n plus 1. And what's going to happen here? One of them cancels. So I have, I'm going to distribute the 2 back in. 4n plus 2 divided by n plus 1. Again, by the way, we're still taking the limit, right? Okay. So they have the same degree, right? So what's the limit going to be? The leading coefficient of the top, 4 over 1, which is equal to 4. And that is bigger than 1. So what can we say? It's divergent. Good. So that means that this one is divergent. All right, so let's try one more for this one, for this test. All right, the series as 1 goes to infinity of 4 to the n times n factorial divided by 2n factorial. And the 2n factorial should be like that. So we're going to see if this one converges or diverges. All right, so my a sub n is 4 to the n factorial divided by 2n factorial. So what is a sub n plus 1?
4n plus 1, n plus 1 factorial, n plus 1 factorial. So 2n plus 2 factorial.
Good. All right, again, these are both positive, so we don't have to worry about putting them inside an absolute value. All right, a sub n plus 1 divided by a sub n. So it's going to be the limit as n goes to infinity. My a sub n plus 1 is this whole thing. Bless you. And then multiply it by the reciprocal of a sub n. Bless you. All right, again, using the last example as my guide, what's going to happen with the 2n and the 2n factorial and the 2n plus 2? What am I going to be left with here? You're close. So look at this one, right? Now it's the opposite. Just flip this around. Because that's how I'm working with, right? So I have, yeah, it's going to be 1 over 2n, what is it? 2n plus 2 and 2n plus 1. And then what's going to happen with these right here? The n plus 1 and the n plus 1s. Yeah, it's going to be the same thing. Yeah. Yeah, it's the same thing as the previous one, but flipped. But we also have to be careful with this, right? So what's going to happen with the 4n plus 1 divided by 4n? What am I going to live with? 4 where? On the top. Yeah, on the top. So this is going to be the limit as n goes to infinity of 4 times what is left on top? n plus 1, n plus 1. And then divided by 2n plus 2, 2n plus 1. And then again, what can I factor out of here? A 2. So I'm going to have the limit as n goes to infinity of 4n plus 1, n plus 1, divided by 2n plus 1, 2n plus 1. So again, the n plus 1s are going to cancel. So I'm going to distribute the 4 back in. So I'm going to have 4n plus 4 divided by 4n plus 2. We have this.
Just cancel a 2.
You can cancel out a 2. But you're still going to be left with a 1, right?
So wouldn't it be like 2 top, 1 on the bottom?
Or either way, you're still going to end up with a 1, right? So your limit's going to go to 1. So what does that mean? Read it again. It doesn't tell you anything. You did all that work for nothing. All right, it's inconclusive. Yeah, inconclusive. So you see for like this example, taking the integral of, I don't even know how to take the integral of a factorial. So doing an integral test would be no fun here. All right, so we know nothing of this series. We don't know what it's doing, if it's converging or diverging. All right, last test, and then we will go. Uno más. Okay. I only have like 2 or 3 examples for this one. All right, the root test. No, keep forgetting, not that one. No, I know. Okay, the root test says if you have a series, it can be any series, positive or negative, and suppose that if you take the nth root of the absolute value of that series, I know that sounds like really complicated, and it equals p, then if converges absolutely if your p is less than 1, a series diverges if your p is greater than 1. That's actually not p, that is, what symbol is that? I forget. All right. Or p is infinite, the test is inconclusive. Again, it's the same thing like the ratio test. But now we're taking the nth root of the absolute value of a series. All right, so let's look at this one here. So we're going to see whether this series converges or diverges by taking the nth root test. So we're going to take the limit. By the way, is this one always positive? Yeah, because it starts at 1, right? Okay. So I don't need to worry about the absolute value. So I'm just going to take the nth root of 2 to the n squared times 2 to the n divided by 2 to the n. All right, so it's going to be the limit as n goes to infinity. And I'm going to rewrite this as the nth root of n squared divided by the nth root of 2 to the n. And what's going to happen on the bottom? Yeah, the nth root and the n cancel out.
So it's going to be the root of n squared all over 2.
So it's going to be 2, right? The nth root of n squared. All right, and I'm going to rewrite the top also using exponents. So the limit as n goes to infinity of n to the 2 over n divided by 2. All right, when I take the limit here, I'm going to have infinity here, right, with that n. But what about here? 2 over n, what is this going to reach? 0. And any number to the 0 power gives me 1. So this is going to equal 1 over 2, which is less than 1, which means it converges absolutely. All right. Let's try another one. All right, 2 to the n divided by n cubed. Well, the limit's going to be different. But it's very similar, right? So we're going to take the, and again, this one's always positive for n greater than 1 or greater than or equal to 1. So it's going to be the limit as n goes to infinity of the nth root of 2 to the n divided by n cubed. Yeah, the n's cancel on top. So it's going to be 2 divided by n to the 3 over n.
That's divergent.
This is going to equal 2, which is greater than 1. So that means that this series is divergent. Good. It just says divergence. The difference is this whole thing right here. Up here, this definition. Yeah. It converges if this also converges. If that converges, then this one converges absolutely. So this one converges and this one converges, and they converge absolutely. No, I'd probably just ask you if it converges. All right, one more example, and then we can go. Yay. All right, last example. Hang in there, you're almost done. And this one's super easy. 1 over 1 plus n to the nth power.
Can't we just distribute the n and just get everything like that?
Well, I want you to do this test. It's much easier if you do this test anyways. Because what's going to happen with the n's? They cancel. So we're going to have the limit as n goes to infinity of 1 over 1 plus n. And what's that limit going to equal? 0, which is less than 1. So that means that this series it converges absolutely. Or absolutely converges, whatever. No, I probably won't. Unless I specifically ask you, like, use this test and tell me if it converges absolutely. All right, we're done for today.